Thank you.
Okay. So basically, uh, basically, we spoke about two kinds of sorting algorithms. The first sorting algorithms are without recursion, and the second ones are with recursion. So basically, today we'll continue with sorting algorithms with the recursion, and we will be able to analyze the time complexity for those sorting algorithm, which is uh, the basic aspect that we are learning sorting algorithms for. So let's have we spoke in the previous time uh, about uh, recursion, and we understood what recursion is. So basically,
Oh, doctor, you're
uh,
lagging, I think.
am I lagging now?
No, doctor, you weren't lagging. You're fine just now.
Yeah, maybe lagging for Muhammad or something. Yeah.
Mhm.
Okay, so yes, am I lagging? Yes or no?
No, you're
Very
not
like
lagging, doctor. We can.
Oh, so in the previous time, we spoke about insertion sorting, and we took insertion sorting based on loops and stuff like this. And the complexity was order of n square. And this is basically how binary insertion sorting is working. So basically, it starts from the first element and then the second element and checks whether the second element is less than the first element. And it goes to the third element and puts it in the right position. It goes to the fourth element and put it in the right position as well. And it goes to the 8, and it is already in the right position, so nothing to be done. The 7, it will put it before the 8. So it basically picks each and every element one by one and compare it to the already sorted elements and compare it to the already sorted elements, and it puts the element at the right location for it. So basically, it goes over n elements, and for each one of them, it scans also n elements and put the new element at the right location for it. So basically, that's why it is in order of n square. That's why it is an order from its square. So now, basically, we will be taking this algorithm, but this algorithm, we will be taking it with the recursion. So we'll be taking this algorithm with recursion. So let's see how it works. So this is how it works. So basically, this algorithm is so basically this algorithm is the binary insertion sort. So what does it take? It takes an array and it takes a size of this array. So this is an array of integer and this is a size of this array. Then it starts with a loop And why does it start with a loop? Because as I said previously, if you look back to the algorithm itself, it goes for each and every element one by one, and it picks and put it in the right position. So first, it starts by a loop, and then, and then, and then it will search using binary search. And I will explain what is binary search is all about. I will explain what binary search is all about. So basically, basically, uh, basically, it will search for the right for the location. It will basically search for the location of this element, and it will simply put it at the location that should be in. So first, it picks each and every element. Second, it does a binary search. It does a binary search for certain element inside the array. And then what does it do? It basically put it at certain location inside the array. And this location is the right location for it. So what is basically binary? What is basically binary search? What is basically binary search? It is basically a search inside a tree, and a search inside a tree. And definitely, I will not give you the details of this algorithm now. However, I want you to be able to understand what is the objective of it. So basically, and then the details of the code, I will give it to you when we are taking trees after we are finished with linked list, which is the next topic that we are going to have. And what is basically searching in a tree? So if you remember, first, what is a tree? A tree is basically a data structure, which is basically something like an array, something like a vector, something like a linked list, the one that we're taking after. So a tree, just this is called a binary tree. And why is it called a binary tree? Because simply it has two children. It has two children, one to the right and the other one to the left. Could you please wait me 1 second? I'm sorry for this. So what we were saying that the tree is a binary data structure. And what does it mean, a binary data structure? It simply means that I am searching inside the array, inside the tree. So I am searching inside the tree. Why it is a binary tree? Because simply it can have up to 2 children. It can have 1 child and it can have 2 children. And if I want to search for 11, for example, so I start by going either to the right or either to the left. So as if I divide the tree by half each time I am searching. And that's why it is called, that's why the time complexity is order of log to log base to the n. It's order of log base to the n. So if this tree is of 15 elements, this means that I will take 3 steps in order to search for the element which is 11, for example. Okay, so basically the binary search complexity is order of log 2 base n. So I want from you to analyze this algorithm and tell me what is the worst case for this algorithm and what is the best case and what is the worst case and what is the best case, provided that binary search is the complexity of binary search is order of log 2 to the base of n. So please analyze this algorithm, write me to the chat in private, of course, and tell me what do you expect the complexity of this algorithm at the worst case and at the best case. So I leave it for 2-3 minutes and then analyze it and let me know what is the time complexity for it.
دكتور
Yes.
معلش انهي الجوريزم بالظبط اللي هي السيرش ولا السورت؟
Binary insertion sort. This one that calls from inside it binary search.
تمام.
So binary insertion sort start with a loop, then I am searching for where I should put the element, and then yes, so someone answered. So Abdurrahman, no, Abdurrahman, that's totally incorrect. Yasin, also that's incorrect. Muhammad Hashish, that's incorrect.
Doctor, can you repeat the question?
So I am asking what is the time complexity for this algorithm, the one in orange, which calls the blue one.
So the blue one is included as long as it's called in the orange one.
Yes,
right?
yes.
Okay.
Dana incorrect. Mustafa incorrect. Yasin partially correct.
Which one?
The first one is correct. The second one.
Second one.
The second one is incorrect. But you may have a logic. So but I know how did you think, yeah. Then it's incorrect. Abdurrahman Magdi, now it's correct. Partially, yes. No, not really, Yasin. Freddy, partially correct, yes. But this is the best case or the worst case?
دكتور احنا المفروض نقول الاثنين البيست كيس والورست كيس.
Yes.
تمام.
Yes, Rada, partially correct. Worst case correct, yes. Okay. So no, Freddy. Okay. So let's have أنا yeah, partially correct. So no, Rada. Hi. Okay, so let's have let me have Freddy with me.
Yes, sir.
So uh, let's analyze step by step. So this for loop, what is the worst case for it?
In for 2.
لا, what is the worst case for this for loop? For loop. This is a for loop. It goes from
اوكي من
where
1
to where.
من 1 لحد
So
ال
what is the worst case
N.
for it?
N.
N. So this algorithm should be equal or greater than N. Yes?
Yes.
Yes. So let's continue. This is a statement, so it's order of 1. This is another statement, so order of 1. So the worst case so far up to this line is order of what?
N.
N. Binary search, it is searching into a tree. So the worst case into it is order of what?
log 2n.
Log 2n. That's fine, because it's searching into a tree. And then this loop, so basically up to the binary search, what is the worst case? Is it n or log base 2n?
N.
N.
Yes. So the issue here for people who said that the best case is order of n, you, Yasin, and some other people. So will this loop be entered, yes or no? Will it always search for the right location or not?
Doctor, isn't there a possibility that
ممكن
it goes through the for loop?
Why there's a possibility?
So it doesn't go through the while loop?
Why there's a possibility not to go through the while loop? It will always search for the best location for the element. It will always search. It will not skip. Even if the location is the right location, which is basically this part. No, not really. Okay. So just let it pass. So for the 5, Freddy and Yasin and all, it will search in 2 elements. The 3, it will search in 2 elements. The 1, it will search for the right location to insert it in 3 elements. For the 8, it is already in the right location, but who says that it will not search for n elements before it? Who says? Maybe you have a logic. We are thinking together, yeah. So is there a way that this while loop can be skipped so that the worst case complexity will be order of n?
Doctor, what's J and what's location? And what are they initialized to?
So So basically, the location is where, yani, look at this algorithm, regardless what they are initialized to, Yasin, because I will explain this when I explain T, but I want the logic first. خلاص. The logic says here, I am asking you, if you look at the 7, خلاص, I am searching it into the 1, 3, 5, 6, and 8. So I am searching into this sub-array. I am searching it as if it's a tree. So I will know where should I put, so the location, I know where should I put this element, which is 7. So basically, my question is, can I skip this loop or not?
مش انا ممكن لو لقيت شافت الرقم اللي قبليه على طول ولقيته اصغر منها ما تكملش؟
مين قال؟
No, I can't skip the loop لأن كده كده ممكن يكون في
ممكن احط انا بقى يعني
هعرف منين؟
شرط يعني.
هعرف منين؟ أنا بتكلم على دي لوحدها. هعرف منين إذا كان أنا ينفع أسكيب؟ even يا زيدان, even if it is an ordered array. Now look, the 7, for example, I want to put it somewhere here. Where should I put it? I should put it somewhere here. So I have to compare all the elements before it to put it at the right location. So still, can I skip or not? Yes, Mustafa.
You can't skip عشان لازم you go after each element. It will have to be
Yes.
minimum of n.
Yes. You can skip or you cannot skip.
You can't skip. It has to go over the elements first.
It has to go over the elements first. Yasin, can it skip or not?
I guess it has to search for no.
You guess you have to?
Search, it has to find the best location, so it can't skip.
It has to find the best location. Yes, exactly. It has to find the best location. So if it has to find the best location, let's go back to Freddy. This loop is order of n. And for each element, it has to find the best location where to insert it. It has to find the best location from where to insert it. So in this way, it is order of n square anyways, or it is simply order of n?
n squares.
It's simply order of n square. So anyone doesn't understand? Adham, you're okay?
تقريبا.
So what didn't you get? By the way, I don't care about the code here because I will explain. I'll explain the code details later when we have these.
هو يعني I need to كده sit with the code لوحدي كده عشان أفهم.
No, you have to sit with the logic, not the code. Forget about the code.
مش عارف.
So I'll explain the logic again. So the logic simply, for each and every number, 6, 5, 3, 1, 8, 7, 2, 4. So for each and every number, I compare the number with whoever preceding it. And I simply put it at the right location. So for each and every number, I compare it with n numbers. And then I put it at the right location. So I compare it with n numbers and I put it at the right location. That's why it's order of n squared.
Okay. That's like the same type of algorithms that we.
Yeah, it's the same type of algorithm, but the first algorithm was built into sequential search. A sequential search, I mean, it's an array, it's a loop, and this one is made using another data structure, which is searching into a tree, but it didn't affect the best, it didn't affect the best case as well. So it remained order of n square at the best case.
Mhm.
Someone explain. So now we're going to have what's so called merge sort. We're going to have what's so called merge sort, and I will not explain merge sort. I want someone to explain merge sort. But before someone explaining merge sort, I will just zoom into it. I will zoom just this place. I will explore, zoom into it, so let you see uh, exactly. And the one who picks the complexity will have uh, will have after seeing the code, of course, will have 5 bonuses. Okay, so I will put this in front of you for 1 minute, and if you understand it, how it works, how it searches, how it is doing sorting, so just let me know on the private chat. So have it for 2-3 minutes in front of you.
دكتور هو بس can you show us the full picture عشان for some reason it's cut out by the taskbar.
Okay, fine. This is the full picture.
Thank you.
Yes, Zidane, that's perfectly correct. Who else? Yalla. Yes, Yasin, that's perfectly correct. Just to help you, start from the top. Yeah, Muhammad, this is perfectly correct. Start from the top and follow the arrows. Yeah, غادة, that's يعني approximately correct. يعني the idea is correct. يلا, move on. Yes, Mustafa also. It's correct. Freddy, yes, correct. Abdurrahman, yes, correct. So, I want to ask you another question. I want to ask you another question. This shape reminds you of what? Write also in the chat. Yes, Ghada, perfect, perfect. Adham, perfect. Mustafa Hashish, perfect. Uh, Carmel, yes, you're right. Okay, that's perfect. Okay, so I will explain it, and then, so I have this array, and then it is splitted into two halves, and this array is splitted into two halves. This array is splitted into two halves, and this array is splitted into two halves. This array is split into two halves, and then after each and every element, I am merging both elements together. So I am merging 27 and 38 in the right order, 3 and 43 in the right order, 82 and 9 in the right order, and then 10. Then I am merging those twos into 327 in the right order. So first, I will ask you and you answer me in the private chat. What is the complexity for the first part? And what is the complexity for the second part? And accordingly, what will be the final complexity? What will be the final time complexity? Answer in the chat, and then let's continue together. Yalla, I need the final complexity. And this thing looks like a tree. So, and this one, you should be able to guess the complexity. So multiply this part by this part, you will get the final complexity. And answer into the chat. Yes, Mustafa, for the first part. Rada, no, not correct. Abdurrahman, wait. No, not really. Ikram, not really. Adham, Rada, not really.
هو انا نوت ريلي ولا عشان سكت
لا, not really. أنا ألدغ بس.
لا مش قصدي كده.
لا, it's okay يعني. خلقت ربنا ألدغ. So يلا. So Yasin, yes, perfect Yasin. You have 5 bonuses. Adham still incorrect. So Zidane, Abdurrahman, yes, it's correct. So you have 5 bonuses. So you have to analyze the first part and then the second part. Rana, yes, 5 bonuses. Okay. No, not real. Mustafa, yes. 5 bonus. Yes, yes, yes. Okay. So, Rana Saleh, can you tell me how did you get it? Rana? So it seems that Rana is disconnected. So I think someone else got it right. So Mustafa, Mustafa Abdel Khaliq, can you tell me how did you get it? So what is the final answer and how did you get it?
Okay, I think the final answer is n log n, because in the
Yes.
first part it is searching in n elements. In the left side it's searching on half n, and the right side searching on the other half. So the total is n search. And in the second one, she's searching like combining each two together and then merging them into 2 groups and then merging these groups. So it's like log n. So to get the whole
Okay.
time complexity, we multiply the both phases together. So we get n log n.
Okay, that's fine. Not Yasin, what's your view since you get it right as well? So what is the complexity for the first part and what is the complexity for the second part and why?
So it has to keep breaking it up into smaller arrays. So this is log n,
Yes,
and then it has to do that n times. So it's the total.
yes, it has to do that in times. So basically, this is very similar. It's in the same complexity. That's why I say very similar. So if you imagine that this is a tree, so this is basically the root of the tree, and I am dividing it into a right child and a left child, and then I am dividing the right child, uh, this element into the right child and the left child, and then this element into a right child and the left child, and then I am dividing this into a right child and the left side. So this process of dividing the array into left child and right child is very similar like searching into the array, and it's basically log base 2 to the n. Why? Because I am breaking a big thing into smaller things, one to the left, and the other one to the right. So this is order of log base 2 to the n. And what is the complexity of this part? So if I have 4 elements like this, so I have to search. So I want to put, say, I want to put 27 at the in the right place. It is already the first element. So I will put it at the, so it is already at the right place. Then 38, I will compare it with 27. So it is already in the right place because 38 is bigger than 27. Then say, I will compare it with 27. I will compare it with 27. And then I will compare it with 38. So the right place is to be before the 37, before the 27. So I am comparing it in times. 43, I am comparing it with 3, it's bigger. With 27, it's bigger. With 38, it's bigger. And 43 will be at this position. So simply, this is merging. And merging, how does merging work? It is basically merging two sub-arrays together. And how does it merge them? It is simply search for each and every element and put it in the right side, which is an order of n, which is based, so the complexity will be order of n log n. So this is basically the concept. I want you to understand the concept, but I will show you the code. This is the merge. This is the merge code. Let's analyze it step by step as time complexity without going into details, So the first part, this is a for loop, so it's order of n. This is the second part, so it is order of n. It's not a loop inside each other. So order of n plus order of n, so it's basically order of n. This is a while loop, so it's order of n also. And this is another while loop, it's order of n. This is whatever the fifth or sixth order loop, so it's order of n. So basically this whole algorithm is order of n. Let's see, this is the merging algorithm. This is the merging algorithm, which is primarily the second algorithm, okay? Let's go and see the merge sort. The merge sort actually calls itself recursively, and it does the division. It does the division of this big array. So either it put it at the right side or at the left side. Either it put it at the right side or at the left side, which is basically merge sort. This is log n. Another merge sort, the left side and the right side. So this is basically log n. This is basically log n. This is basically log n. And this is basically n. So what will be the time complexity? It will be n log n. That's why it is basically n log n. Okay, here I want you to understand the concept. I don't want you to understand to know the exact coding for this. Yes, Zidane?
Doctor, I have a question.
Yes.
The complexity is measured by the worst case scenario, correct?
Yes.
So how is it not n?
Because simply this one in the worst case it's log n, and this one in the worst case it's n. So it's
So
n log n.
So shouldn't the complexity be n?
No, if you have a recursion, so it's as if it's inside each other, yeah, Mustafa.
Oh, okay. So if there's if a recursion occurs, it becomes automatically logarithmic.
Yes, exactly.
Okay.
Why it's in log n? Once again, if you go at the first part, yeah, Mustafa, this is the algorithm that is called merge sort. So this thread element is the same as this thread box is the same as merge sort and merge sort. So it is log n. And for each element here, 37, 27, 43, 3, for each element, 9, 82, 10, it is merging them together. So how many elements are we merging? How many elements are we merging, Mustafa?
The 7 elements?
That's, which is? If it is not order of 1, so it's order of what?
log n.
Sorry, I mean, if I am merging 7 elements, so as if, so it is basically I am merging n elements. Yes.
Yes.
Yes. So
it's n.
so I split it in log base 2n, and I am merging those elements in n times. That's why it is n log base 2n.
Okay. Thank you.
So I want you to understand the concept. Do you have difficulty understanding the concept? Don't look at the code يا Adham. Understand just the concept. So the concept again is basically splitting this array is order of log base 2n, and merging them together is order of n. So the overall complexity for the algorithm is order of n log n. Okay, any questions? Should I move? Okay.
دكتور وانا I understand the logic بس انا I face difficulty يعني لما باجي اشوف measure time complexity مش بمشي فيها قوي الصراحه.
لما تميجر تايم كومبلكسيتي للالجوريزم بصفه عامه ولا
يعني
لذيس
في شويه بيجوا بس مثلا انا دي ما عرفتش اعملها قوي الصراحه.
ما هو طبيعي يعني I mean this is not something that you can pick يعني from the first time يا مصطفى يعني لكن الرول what does the rule says? If I have one loop from 1 to n, so the worst case is n. If I have 2 loops inside each other, what will be the time complexity?
تبقى n squared.
n squared. طيب, if I have one loop and tree splitting or searching into the tree, it will be
log n.
And then I will do it n times, so it will be overall
n log n.
Exactly. That's it.
ماشي.
So simple. Yeah. So you have to take it by logic, not by. You have to look at the code, not analyze each and every time, each and every line. You have to look at the code, see where are the loops. If we have some loops that are not entered at all inside each other, so it will be order of n. If we have 2 loops inside each other that they have to be at the same time together, so it's order of n squared. Yes?
Okay.
Okay. It's easy?
thank you دكتور.
دكتور انا بصراحة حاسس ان انا مفهمتش قوي الميرج، مش حاسس ان انا فهمتها خالص بصراحة، متلخبط فيها قوي.
ما انا ده اللي لسه شايحها الحشيش.
مع ان برضه يعني حاولت اكاتشت بس لا مش قوي.
طيب تاني but you will be with me. This part is very similar than searching into the array, searching into a tree. What is the time complexity for searching into the tree, Muhammad?
Time complexity
For searching into a binary tree.
n number.
No, it's order of log base 2n.
تمام.
You attended the previous class?
لا not all. انا حضرت اونلاين بس ما كملتوش.
طيب you
I had a
have
problem with the connection.
You have to see the recording and then study the lecture and then come back. I can explain again. Yeah. So, but in general, searching into the binary tree takes order of log base 2n, and then merging each and every element here takes an order of n. Why it takes an order of n? دلوقتي 27 and 38. so they are in the right location. I want to put 3 at the right location. So I ask 3, are you less than 27? Yes, so I put it here. Type. I want to put 43 at the right location. Are you bigger than 3? Yes. Are you bigger than 27? Yes. Are you bigger than 38? So I repeat this step for n times. That's why the merging is order of n. And the splitting, this part, is basically order of log base 2n. Okay, because I am doing it for the left hand side and the right hand side. So as if I am splitting the tree to the left side, to the right side, and to the left side. So try with yourself and let me know if you still have difficulty. Okay.
تمام. Thank you doctor.
Okay. Actually, يعني I was intending to explain this linked list using Legos and stuff like this. I will still do this again on Thursday. Inshallah, and I'll give you a brief idea about the linked list. And on Thursday, to be just fair with you, and like the other class who attended yesterday face to face, so I'll explain the idea, and then inshallah I will repeat everything on Thursday. And unfortunately, Thursday will be somehow a long lecture. So I will explain the brief idea about the linked list to know it before the lab. And then later on, I will explain it again on Thursday, inshallah. So basically, this is a linked list, and a linked list is very similar to what? It's a data structure, and it is very similar to what? Someone tells me. It's very similar to what?
arrays.
It's very similar to array. What else?
Stacks
Read.
and rows.
It is very similar to what? The array, yes. And what else?
3.
No, not 3.
I said
3 is always hierarchical.
Vectors, a doctor.
It's very, yeah, thank you, Ali. It's vectors. Thank you, it's vectors. So basically, it's very similar to, it's very similar to the vector. It's very similar to the vector. So does it contain homogeneous elements or heterogeneous elements? Homogeneous elements means that they are elements of the same type. Heterogeneous elements means that they are of different types. So homogeneous elements or heterogeneous elements?
Homogeneous.
Homogeneous elements. Why? Because all of the elements should be integers, should be doubles, should be whatever. Okay. A linked list contains 2 parts. A linked list contains 2 parts. This is the first part, and this is the second part. The first part is called the element of the linked list, the data elements from the linked list. And this second part is actually a pointer to the next element. And the next element has a data element and a pointer to the next element. And Mustafa, can you put yourself on mute? Okay. And then this pointer points to the next element, which is 47. And then it has a data element and a pointer to the next element. And at the end of the day, this linked list this linked list is complete. So it's very similar to something in real life. What is it? Someone tells me. A very famous thing.
بتفكرني بقطر مش عارف ليه.
ترين يا دكتور.
Legos.
Tayin. Yes, it's a
Oh.
tayin. It's tayin. You know, the tayin, you have يعني the head of the tayin, عربية القطر الأولانية. And if you have the head, then you are linked to each and every part in the tayin. Each and every part in the tayin, if you العربية الجرار يعني. If you have this head, then خلاص you can go into the tayin, into the elements of the tayin one by one. So basically you have the head of the tayin and you have data elements and you have the data elements. You have the head, it points at the first element. This is a pointer. It points at the first element. So it simply points at 21. And then 21, you have a pointer to the second element. And the second element has a pointer to the third element. And then the third element has a pointer to the fourth element. And this is finally the complete linked list. If you miss the head of the tayin, خلاص you don't have a tayin anymore. You don't have a tayin anymore. Okay? So someone tells me how to search into this linked list for 47 as a logic. How to search into it. Forget about C++. Just a logic. How to search into 47.
How to search for 47?
Yes, how to search into 47.
هدور
بعمل بوينتر وبعد كده بيبوينتس للهيد وبفضل امشي بالبوينتر ده للسكند اليمنت والسكند اليمنت والسكند اليمنت لحد ما ريتش.
Yeah, that's fine. That's fine. Thank you, Fede. You have 2 bonuses. Okay. So, how to search for 47? We will repeat this in next time, inshallah. How to search for it? So, I put a pointer at the same place at the head. And then I point at 21. And then I ask myself, are you 47? No, I'm not 47. And then I go to the second element, 35. Through this pointer also. I ask myself, are you 47? No, I'm not 47. Then I ask myself to the 47, are you 47? Yes, you're 47. So you simply place a pointer here that is called current, and it points at the first element. And then I ask myself, are you 47? No. Then you put the current at 35, the current pointer at 35. Are you 47? No, I'm not 47. And then you go to the third element and it's really 47. So once again, I finished early today, like 20, 30 minutes, 20, 25 minutes. However, expect on Thursday that we stay later 20, 25 minutes in order to show you this thing on actual using Lego and using some visual demonstration. So thank you for attendance and see you Thursday, inshallah. Yeah, that's fine. I will put yes. Yes.
So Thursday هنقعد يعني زي كالعادة 7 إلا ربع كده 6 ونص صح؟
بالظبط عشان خلصنا النهارده بدري بقى.
تمام.
Thank you.
Okay.
Thank you يا دكتور.
Thank you.
Thank you دكتور.
Thank you, doctor.
Thank you.
Thank you, doctor.
Thank you.
دكتور هو كده اللعب هيبقى برضه الساعة 7؟
إن شاء الله.
اوكي ماشي. Thank you.
Yes, Mustafa, you can ask.
حضرتك بس كان عندي شوية أسئلة عن ال complexity.
Okay, أنا معاك.